good day. How's it going?
How's it going, eh?
2 topics today, back bacon and long underwear.
Oh, geez, eh? Some hoser played the wrong tape. Those are not today's topics. Good one. Good day, eh? And welcome to the RC Stories Garage. Today's topics are beer and winter. That's right, because the best way to survive winter is with beer. So, take it away, narrator guy. Good day, eh? Welcome to the RC Stories Garage, and welcome to Canada, eh? Actually, today's topic is installing brushless motors in a Kyosho Trail King tracked vehicle. But the boys are right. Winters in the Great White North are long and snow is a constant challenge. Driving our Snowcat-inspired Trail King makes winter bearable. And beer, eh? Right. We recently installed metal tracks on our Trail King and decided it was also time to upgrade to brushless motors. The stock Trail King is powered by 2 340 sized brush motors and ESCs. Recently, Hobbywing introduced their first 1/16 scale Fusion motor, the quick-run Fusion Mini16 with FOC. Fusion motors are usually used in rock crawlers, but can be used in other high-torque, moderate-speed applications as well. The built-in, highly programmable Fusion ESC makes for a streamlined installation. Beauty, eh? Though Hobbywing primarily advertises the Mini16 as a 1/14 or 1/16 scale power system, we figured 2 motors could power the 1/12 scale Trail King. With our metric ruler in hand, we checked to see if the Mini16s would fit in the Trail King. The stock motor cans, including power wires, are about 40 millimeters long, like the size of a mini donut, eh? The Mini16 motor can and ESC is 42 millimeters long. It will fit fine in the Trail King, but would interfere with the plow blade function of a Blizzard 2.0 without further modifications. The Mini16 is a moderately fast 3000 kilovolt motor. We don't want the cops giving us tickets, eh? We are switching from a 2S to a 3S battery, so that alone will give us 30% more track speed. Good stuff. We started the installation by pulling out the servo and links for the shop-made snowplow blade. Our Blizzard 2.0 has taken over trail and road maintenance duties. Then we removed the stock motors and ESCs. The Kyosho Trail King and Blizzard 2.0 come with 48P 16-tooth pinions, but it is recommended to run 13-tooth pinions with the metal tracks. We had 13-tooth 2mm bore pinions installed on the stock motors, but obviously these are not going to work with the Mini16's 2.3mm shafts. Looking further, we realized the shaft length on the Mini16 was also going to be a problem. The position of the flat on the motor shaft, coupled with the very long axial pinion gear, meant the pinion was not going to mesh longitudinally with the transmission gears. Luckily, we always keep a supply of aluminum spacers in the garage. Mounting the Mini16s on 3mm standoffs aligns the pinions properly. We don't love the space between the motor and motor plate, but quick tests have not exposed any flex issues. Alternatively, one could use Hobbywing's 340 to 540 adapter plate as a spacer. This adapter is exactly 3mm thick and would provide slightly more contact surface at the motor plate. However, the fact is that the transmission mating surface is not completely flat, so the slight additional stability gained by spacing with the adapter plates would come at the expense of added weight. The final issue that arose while test fitting the motors was caused by the overly long pinion gear grub screws provided by Axial. These M3 by 4mm grub screws, when installed, collide with the inside of the motor plate shaft opening. Again, luckily, we have a supply of various grub screws in our hardware box, including some M3 by 3mm screws. These mounted flush with the pinion when installed. The stock ESCs are wired to the battery and power switch harness with Dean's connectors. The Mini16 ESCs come wired with EC2 connectors. We run XT60 rather than Dean's connectors on our trucks. Deans are electrically very good, but hard to deal with when unplugging batteries on a regular basis. However, in this scenario, since the Mini16 ESCs are never unplugged from the wiring harness, we decided to keep the Dean's connections. Of course, this meant a skidoo ride to the local hobby shop on the other side of town to pick up some Dean's plugs. While there, we also bought a cool carbon fiber soldering jig that has functions for clamping wires and holding Dean's, XT60, and bullet connectors. Back in the garage, we cut off the EC2 plugs and soldered on male Dean's plugs. We love our Weller WE1010 digital soldering station for this type of work. It gets hot quickly and has loads of different tip shapes and sizes. Of course, sending the power from two ESC BECs to the receiver would be a bad idea, though that seems to be how the stock ESCs were configured. Go figure, eh? To be safe, we decided to make a short servo wire adapter so one of the Mini16 ESCs has a ground and signal connection to the receiver, but no positive power wire connection. The alternative is to cut or de-pin the power wire from the ESC communication wire. After making the ESC adapter, we hooked up all the electronics outside of the vehicle to make sure everything worked. The plan is to leave the Mini16 ESC switches on and tucked away in the voluminous receiver box, and to turn the vehicle power on and off with the stock switch on the battery cable harness. Our test showed that this works flawlessly. After sorting out the fitment and electronic issues, we were finally able to install the motors. Gear mesh was set as per usual with a piece of 20-pound bond paper. The motor ESCs are plugged into the steering and throttle channels of our Spectrum SR515 receiver. We use a DX5 rugged transmitter with channel mixing to drive and steer the Trail King one-handed with the trigger and the steering wheel. Leave a comment below if you would be interested in a video on how we set up the transmitter channel mixing to achieve this. If you're going to get into the Hobbywing Fusion ecosystem, make sure you buy one of their programming cards. One card will work for all models. We keep the PDF manuals with function lists on our phone for instant reference. After a test drive, we tweaked a few ESC settings. First, we reversed the motor rotation of one of the motors in the ESC rather than doing the reversal in the transmitter. Fusion motors work best when the ESC knows which way forward and reverse are. Duh. We changed the running mode of both ESCs to option 3, forward and reverse, or normal mode. The default FOC RPM matching mode was jerky on this dual motor tracked vehicle. Likely the two motors were oscillating or seesawing off each other, resulting in less than stellar steering. We reduced the punch setting to level 3, again to smooth the startups. Snow and ice are, by their very nature, low traction surfaces. And finally, we set the neutral range to option 1, which is 4%. Since we are steering and driving with a mix of trigger and steering wheel, it feels better if both inputs engage as close to the neutral position as possible. There is no issue with the motors engaging without input, though we did have to set slight offsetting trims on the two motors to get them to start at exactly the same moment. We could feel that the vehicle was stopping rather quickly when we let off the throttle. This is probably due to the strong drag brake all Fusion ESCs are famous for. Rather than going through multiple trial and error tests, plugging in the programming card, changing the drag brake force on two ESCs, remember, reconnecting the ESCs, and going for another test drive, we decided to hook up the on-the-fly drag brake function of the ESCs. In a rare moment of genius, we realized we could run both ESC drag brake signal wires off a single receiver auxiliary channel and transmitter input if we made a custom Y-splitter servo cable adapter. The signal output of the receiver auxiliary 1 channel is sent to both ESCs in parallel, so making a change at the transmitter affects the drag brake of both ESCs simultaneously. Brilliant, eh? At the highest transmitter setting, the drag brake operates at the drag brake force specified in the ESC. The default is 60% drag brake. With a few clicks of a button, we can dial down the drag brake or turn it off completely on the fly. We want Hobbywing to add this to future 1/10 scale Fusion motors. The dual Hobbywing Fusion Mini16 motors fit nicely, with a little creative improvisation, in the Kyosho Trail King Blizzard 2.0 chassis. The motors drive great, starting up smoothly and dancing across snowy surfaces at top speed. We are glad the receiver box is so large, since it has to enclose such a rat's nest of wiring. The stock wiring was no better or worse though, and once bolted closed, everything looks clean. After some running of the Trail King, we will decide if we want to put the dual Fusion Mini16 setup in the Blizzard groomer. More power, eh? After an hour of driving in -4 degrees Celsius, the motor is maxed out at 26 degrees, and we used about 25% of a 4300 mAh 3S battery. That's it for this episode. Thanks for watching. Don't forget to like and subscribe if you want to see more Canadian content like this, and leave a comment below if you've upgraded the power system in your Kyosho tracked vehicle, or are considering installing the Hobbywing Fusion Mini16 2-in-1 brushless system in any other scale vehicles. Now, you hosers, take off, eh?
I think that was like...
The worst show we ever
No.
did. Is it being worse?
No, it was a good show because like we had two topics.